Now let's talk about other features of a frequency distribution. We're going to be talking about cumulative frequency, relative frequency, percent, and class midpoint. Let's start with cumulative frequency. So cumulative frequency is calculated how many data values accumulate as you go from top to the bottom. Okay, so for example, in the first class, we have 3 values only. And then when we go down and include the second class, we're going to have 3 and 3 more, that's 6. And then when we go down and include a third class with that, with those 2 classes, then we're going to have 6 plus 5, that's 11, the cumulative frequencies of 3 classes. And then when we go down, we include the frequency of class 4. So that's going to be 11 plus 2 is 13. The cumulative frequency of the 4th class is 13. And then when you go through the last class, that's 13 plus 1, that's a 14. And that's usually the cumulative frequency of the last class. It basically accumulates all of the data values included in the table, so that should be equal to your sample size, the 14 that we already seen. Okay, so what's the relative frequency? That's basically the relative frequency tells us the portion of the data values that are located in that specific class. So to find the relative frequency, you would go the frequency of the class, which is 3, divided by the total number of frequencies in that class. So for this class, it's going to be 0.214. Well, for class number 2, we have the same situation. So this is 3 out of 14, and this is again 0.214. For class 3, we have 5 values in that class. So the relative frequency will be 5 out of 14, and that's going to be 3.352. The next class is 2 out of 14, and that's 0.143. And for the last class, it's going to be 1 out of 14, and that's 0.071. Okay, so that's nice and dandy. We have a basically a percentage in the decimal form, but people are usually not used to seeing percentage in the decimal form, so we have to convert it into percent form. So to convert to a percent form, what you would do, you would take each of these values, multiply by 100. So 0.214 times 100% is 21.4%. That was ugly, so I redid it. Okay, so we have 21.4% of all data values in that fell into the first class. So if we continue doing that for the second class, it's also 21.4%, same as for the first, because we have the same number of values in there. For the third class, it's 35.2, and if you notice, what I'm doing, I'm just multiplying by 100 is easy. So you just move the decimal point 2 places and you get 35.2. For the next one, it's 14.3. And for the next one is going to be 7.1. Okay, again, move decimal point twice to the right, and you get your percentage representation. So this is called a decimal form. This is a percentage form or percentage representation. Okay, so that's percent. Now let's talk about the class midpoint. And before we move on to that, I just wanted to mention that the reason, again, to remind you, the reason we're using the frequency distribution is when we have a large amount of data, and it's very difficult to view and analyze it if we just have this huge string of numbers. So it's more like visually more pleasant and easier to work with if we have it in a group like this, in groups like this, and also for the qualitative data type. This is more appealing. But imagine one disadvantage of the frequency distribution. If you're not a researcher, let's say, and you don't have access to the raw data, and you're just consumer and you're basically trying to read the frequency distribution that someone already organized into groups for you, you don't have the raw data. All you have is this. Okay, so you have groups and you have frequencies. So all you know is that, okay, you have 3 data values that are between 60 and 62. What are they exactly? Were the 3 of 60s, or the 3 of 62s, or the 3 of 61s, or any combination of those 3 numbers are possible. Okay, so you don't have the access to that information anymore. So when performing calculations, you're going to assume that all of these we're going to use the averages of those values, okay? And that's going to be our class midpoint. So to find the class midpoint, you're going to average the lower class limit and the upper class limit. So for class 1, or for group 1, is going to be 60 plus 62 divided by 2, and that's going to be 61, okay? Now for, so that's the midpoint, and you can see that's the value right in the middle between 60 and 62. We're gonna do that the same thing for the rest of our classes. So for the second class, we're gonna do 63 plus 65 divided by 2, and that will give us 64. But here's another thing that I want to point out. Remember how we said that the distance between these values are 3 units, which is our class width. Same here between these values. You're going to see the same pattern with the class midpoints. So 61 to 64 is 3 plus 3, right? So the next one would be plus 3. 67, the next one plus 3, 70, the next one plus 3 is 73. So guys, now it's not that you're always going to add 3. It's whatever your class width is. That's the number that you're adding. I just wanted to make sure you understand that. And how do you get that number? Well, you find the difference between the 2 consecutive lower class limits or 2 consecutive upper class limits. That's your class width. And that's what you use to figure out the class midpoints.